Hello everyone, this is Chirag and our today's topic is basic electrical engineering. Why I choose this topic? Because before going further in electrical engineering, we have to know about the basics of electricity or basics of electrical engineering. First of all, we have talked about for whom this subject is beneficial. For 12th class student, this is very beneficial because in the 12th class, student go through from to the Ohm's law, Kirchhoff's law, that means KVL, KCL, and various type of basic circuits. For first year students of engineering, no matter student take which branch. Suppose a student took electrical, computer science, mechanical, but he have to study about basic electrical engineering subject. For electrical engineering and electrical and electronics engineering also, and as well as GATE. For GATE, this subject is very important, but this is basic subjects. So we have took some measurement or some points of basic electrical engineering. First of all, in basic electrical engineering, we have studies DC circuits. In DC circuits, there are some things like resistance and all, voltage sources, current sources at DC. Second thing, AC circuits. In AC circuits, we have studied impedance, which is denoted by Z. Similarly, inductance, capacitance also. Further, in basic electrical engineering, we have studied magnetic circuits. Further, DC machines and all. And as this is my first video, we have talked about DC circuits, and later on we will discuss in other videos AC circuit, magnetic circuit, DC machine, as well as further constants. If we talk about DC circuits, we have some measurement like Ohm's law, which is very basic law of basic electrical engineering. Further, KCL, KVL, Kirchhoff's current law, and Kirchhoff's voltage law. After this, we have to reduce the circuit. So, for reducing the circuit, we learn two theorems like Thevenin theorem and Norton theorem. Further, in theorems, we have studied superposition theorem, which will deal in two or more power sources. Similarly, maximum power transfer theorem. In DC circuit, we have discussed Ohm's law, KCL, KVL, Thevenin, Norton, superposition, maximum power transfer theorem, and all. So, the first thing is Ohm's law. By the definition, Ohm's law states for voltage, state in voltage and current. So we can see that in a conductor, suppose this marker is a conductor and it has 2 points, point A and point B. Similarly, this is a conductor. This is point A and this is point B. So there is a potential difference between point A and point B. So Ohm's law states that the potential difference in a conductor is potential difference. We can denote potential difference by voltage. So Ohm's law denoted that the potential difference between a conductor is directly proportional to the current flowing through it. So V is proportional to I. If we talk about further, it is written as V is equals to I into R. So here proportionally constant is resistance. And what is resistance? Resistance is an element which opposes the current from the supply. So R is equals to rho L upon E, where rho is resistivity, L is the length of the conductor, and A is the area of the conductor. So this is basic Ohm's law. Now, what is V is equals to IR? As I have noted, V is equals to IR is Ohm's law. If we talk further, why we have to choose KVL and KCL? That means Kirchhoff voltage law and Kirchhoff current law. Why we can't use V is equals to IR, that means Ohm's law, in further circuits? Because if you want to choose, suppose this is a network. If you choose Ohm's law to solve this network, and so you have to find voltage drop or voltage rise. What is voltage drop, voltage rise? I talk further. So you have to find voltage drop or voltage rise of each and every element of the circuit, like this and this. For all these circuit, all these parameters, all these equipments, you have to find V is equals to IR, that means Ohm's law. So we have designed some laws, that means Kirchhoff voltage law and Kirchhoff's current law. Kirchhoff is a scientist's surname. So it gives two laws, KVL and KCL. Now if we talk about KVL and KCL, that means Kirchhoff voltage law and Kirchhoff's current law. Energy conservation theorem denoted that energy is neither created nor destroyed. That means energy is fixed. Similarly, energy conservation theorem is applied in KVL, and charge conservation theorem. Charge conservation theorem is state that at a node, the charge is given to the node is equal to going charges from the node. This is called charge conservation theorem, which is applied in KCL. Now I talked about voltage drop and voltage rise. So I took two batteries. This is exactly same batteries. This is plus and this is minus. This is plus and this is minus. But the basic difference is the current direction. Suppose the current direction in this battery is like this and this battery like this. So this is voltage rise because the current direction is from negative to positive potential, or we can say that the current is going away from the positive terminal. In this, current is coming towards the positive terminal, so it is voltage drop, which is used for KVL mostly. Now, what is KVL and what is KCL? First of all, I will talk about KVL. That is Kirchhoff's voltage law. According to definition, Kirchhoff's voltage law states that in a closed loop or a closed mesh. Now, what is the difference between loop and mesh? I will talk further. So, according to KVL, in a closed loop or a closed mesh, the voltage drop or voltage rise is equal, algebraic sum of voltage drop and voltage rise is equals to 0, or we can written it as summation of all the EMFs in the circuit and summation of all the voltage rise or voltage drop, which is denoted by I into R, that is equals to V, is equals to 0. This is the basic equation of the KVL. Now, what is mesh and what is loop? Let me take a circuit. Suppose this is a circuit, and let me denote the names of nodes A, B, C, D, E and F. Mesh. What is mesh? Mesh is a closed or a closed circuit in which no other mesh included. That means A, B, C, D, A, B, E, F. This is A, B, E, and F. This is a mesh because there is no other meshes in between this. And B, C, D, E. This is also a mesh because no other mesh is included in this. But if you talk about A, B, C, D, and F, A, forget about B, A, C, D, and F. This is not a mesh because there are already two meshes available in this closed circuit. So mesh is a closed path or closed circuit in which no other mesh is involved. But what is loop? The basic definition of mesh and loop is just equal, but a loop is in which many meshes can be included. So ACDF is a loop. This is also a loop, and this is also a loop. So for KVL, we have first identified all the loops and all the meshes. So let me take an example for this. This is 10 volt source, this is 4 ohm, this is 2 ohm, this is like 4 ohm, 4 ohm, 2 ohm. And the question is, you have to find the current following this 2 ohm resistor. The direction of current may be this or like this. So the question is, what is the current of 2 ohm resistor presented between two meshes? Now, to solve this circuit, this type of circuit, you have to first identify all the meshes. So there are two meshes. First is this and second is this. First step, you have to identify the meshes. This is completed. Step number 1. Step number 2 is you have to identify the current direction. So you can identify the current direction like this. That means clockwise direction. You can also take anti-clockwise direction like this, but the answer is the same. No matter, you can choose clockwise, anti-clockwise. This is not a concern. This is the second step. Third step, you have to apply mesh analysis. What is mesh analysis? This is not nothing, but it is a KVL. And what is KVL? All the voltage drop and all the EMF, algebraic sum of all the EMF and all the voltage drop is equals to 0. So what is this? If I talk about this is positive terminal, this is negative terminal, and the current direction is this, that means the current is going away from the positive terminal. And if you talk about this, so this is the voltage rise, and voltage rise is denoted with positive, and similarly voltage drop is denoted by negative. All the resistance are passive elements, so in every resistance there are always a drop, voltage drop. So this is positive terminal, this is negative terminal, this is positive terminal, this is negative terminal. So if I apply the mesh analysis in mesh 1, what is this? Positive 10 volt, this is 10 volt. If I go through this is the voltage drop, that means negative, and let me define the current, that is I1 and that is I2. If the current is following through this 4 ohm resistor, minus is because of voltage drop. So what is the voltage? V is equals to IR, that is the Ohm's law. Here we require Ohm's law. So voltage of this voltage drop is equals to current and resistance. And what is the current? Current is I1 and resistance is 4. Now, what to do with this? Because 2 ohm resistance, this 2 ohm resistance is included in both the meshes. So here are two current following. One is this and second is this. The current direction of loop mesh 1 is this and the current direction of mesh 2 is this. So from 2 ohm resistance there are two currents, I1 and I2. and both are in opposite direction. So we have to take I1 minus I2 or either I2 minus I1. But remember one thing, if you work on mesh 1, so you have to take reference as I1. So I1 is bigger than I2. So I can write minus for voltage drop, I1 minus I2, I explained already, into resistance, that means 2 and is equals to 0 because the algebraic sum of all the voltage source and EMF is equals to 0. This is the mesh 1 equation. Similarly, mesh 2. In mesh 2, what is the current direction? This is clockwise, I2. If we are going from 2 ohm resistance, that is 2 ohm, but here we have to take the reference is I2 minus I1. Here the positive, negative, positive, negative, positive, negative and positive, negative. If I take a voltage source also, suppose this is 5 volt, okay, so this is 2 I2 minus I1 because I2 is a reference, minus from this 4 into I2, coming to this minus 4 into I2, coming to this is positive, this is negative, and the current direction is going like this. And what is this? This is voltage drop. So minus 5 volt, and from this minus 2 into I2 is equals to. Now we have equation 1 and equation 2. There are two variables I1 and I2, We can solve this by substitution method, and we can find the value of I1 and the value of I2. From the value of I1 and I2, we can minus this, and we can find out the current following through the 2 ohm resistance. If I1 minus I2 is positive, so we can say the direction is, if I take the mesh 1, I1 minus I2, this is positive, then I1 is greater, that means the current direction is this. If this is negative, then the current direction is this. We have to tell the current with the direction also. So this is the basic concept behind KVL. You can solve now. I have all explained the concept of KVL. Now the second point is KCL. What is KCL? Kirchhoff's current law. Kirchhoff said at any node or a junction, we can say this is a node or a junction, all the current meeting to this, the algebraic sum of all the current meeting at a point or a node or a junction is equals to 0. Let me take a 5 wires or 5 lines coming towards or outgoing from the node, and the current direction is that I1 coming towards, I2 going away, I3 coming towards, I4 going away, I5 coming towards. Now if you take all the current coming towards are positive, there is no problem. You can also take all the coming currents as negative, but all time you have to take this. You can take positive for coming current or negative for coming current. Let me take positive for coming currents. So the coming current is I1, that means positive I1. Outgoing current, that means I2. Coming current, positive I3. Outgoing current, minus I4. And the coming current plus I5 is equals to 0. According to this, we can state that the algebraic sum of all the current coming towards or outgoing current is equals to 0. That is KCL. Or in other words, if I take all the coming currents together, I1, I3 plus I5 is equals to I2 plus I3. So we can say that all the coming currents is equals to all the outgoing current, which is nothing but charge conservation theorem. Thank you so much. We will meet again in my next lecture by superposition theorem. maximum power transfer theorem, Norton and Thevenin.